Now for the last part of this question then, we've got to show that the root alpha equals 0.80157 to 5 decimal places. And to do this, what I do is I draw a number line and I put the root that we're testing, alpha equaling 0.80157. I put it in the middle of this number line. And if we're giving this to 5 decimal places, the number before it would have been 0.80156, and the one after it would have been 0.80158. So if we are to decide if this root is equal to 0.80157 to 5 decimal places, then it means that there must be a change of sign in this interval going from the midpoints of these two values and the midpoint of these two values. The lower one would have been 0.801565, and this one here would have been 0.801575. Alright? A change in sign. Remember that we saw that the graph went from negative to positive in the interval 0.75 to 0.85. So we're hoping that the graph comes up through here. Let's just mark the graph in. We're hoping that it comes up something like this through here. Okay, that there's a change in sign between these two values. And if it does, then we know it must be closest to this value, to 5 decimal places. So that's basically how we're going to look at doing this problem. We just need to do f of this lowest value here, 0.801565. Substitute this into here, as we did in the very first part of the question, and see what we get out. Well, if you do that on your calculator, again, remember to be in radians mode, you should find you get minus 2.70 and so on, multiplied by 10 to the minus 5. Most importantly though, a negative value. And similarly, if we do f of this upper value here, 0.801575, put that value through your equation here, you'll find you get 0.620 and so on, multiplied by 10 to the power minus 6. A positive value though. So therefore, again, since a change in sign, we can say that therefore alpha, that root, equals 0.80157 to 5 dp, 5 decimal places. And that's how I'd answer that question.